In this video, we'll break down GraphRAG in a simple, practical way. We'll see how it extends traditional retrieval-augmented generation by using graphs, why that matters for reasoning over relationships, how the system works step by step, where it is used in the real world, and what challenges still remain. And yes, we'll pause for a few quick quizzes so you can check your understanding as we go. GraphRAG is basically an advanced version of Retrieval-Augmented Generation, or RAG. In normal RAG, the system retrieves semantically similar text, usually through vector search. GraphRAG goes one step further by bringing in graph-structured data, especially knowledge graphs. That means it does not just look for similar text, but also understands how entities are connected. This makes it much more useful for domain-specific questions where relationships matter. Traditional RAG is helpful, but it has limitations. It is good at fetching similar pieces of text, but it often struggles when a question requires reasoning across multiple connected facts. This is especially a problem with private, structured, or highly relational data. For example, if a query depends on indirect links between people, concepts, or events, plain vector search may not capture that properly. That is where GraphRAG becomes valuable. In GraphRAG, information is organized as a graph. Nodes represent entities like people, places, or concepts. Edges represent relationships between them. Labels add extra meaning by defining categories or attributes. So instead of storing only chunks of text, the system can represent a fact, like Albert Einstein developed the theory of relativity, as a direct relationship in the graph. This structure makes retrieval more precise and reasoning more natural. Take the question, who developed the theory of relativity? A traditional RAG system might search for similar text and hope the right passage appears. GraphRAG can do better because the graph already stores the relationship. It can locate the node for theory of relativity, follow the developed edge, and reach Albert Einstein. So the answer is not just similar text retrieval, but relationship-aware retrieval. Now that we've covered GraphRAG basics, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. What makes GraphRAG different from baseline RAG? The correct answer is, it incorporates graph-structured data. GraphRAG extends traditional RAG by using graph-structured data, such as knowledge graphs, so it can reason over relationships. Question 2. Why does traditional RAG struggle with some complex queries? The correct answer is, it lacks strong handling of relationships between entities. Traditional RAG mainly relies on vector similarity, so it can miss relational context and multi-hop reasoning. Question 3. In a knowledge graph, what does an edge usually represent? The correct answer is, a relationship between entities. Nodes represent entities, while edges capture the relationships connecting those entities. GraphRAG typically works through 4 main components: the query processor, the retriever, the organizer, and the generator. Each one has a clear role. First, the system interprets the user query. Then it retrieves relevant graph data. After that, it cleans and refines what was found. Finally, it generates a grounded answer. Think of it like a pipeline, where each stage improves the quality of the final response. The query processor starts by identifying important entities and relationships in the user's question. Techniques like named entity recognition and relation extraction help map the query to nodes and edges in the graph. Tools like Cypher can then query the graph directly. After that, the retriever searches the graph using both semantic and structural signals. It may use graph traversal methods like BFS or DFS, and in advanced systems even graph neural networks or adaptive retrieval strategies. Once relevant graph data is retrieved, the organizer cleans it up. This may involve pruning irrelevant nodes, re-ranking useful paths, and preserving the most meaningful context. The aim is to keep the graph compact and relevant. Then the generator uses this refined graph data to produce the final output. In many cases, that means an LLM writes a natural language answer, but GraphRAG can also support scientific or structured outputs like new graph creation. Now that we've covered system workflow, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. Which component identifies key entities and relationships in the user query? The correct answer is query processor. The query processor preprocesses the query and maps important entities and relationships to the graph. Question 2. What is the main job of the organizer in GraphRAG? The correct answer is to remove irrelevant or noisy graph information. The organizer refines retrieved graph data so the generator gets clean, relevant context. Question 3. Which of these may be used by a GraphRAG retriever? The correct answer is graph traversal algorithms. GraphRAG retrievers can use graph traversal methods like BFS and DFS along with other graph-aware techniques. GraphRAG has strong real-world applications. It can support query-focused summarization by pulling together diverse insights from large datasets like podcasts or news archives. It can improve personalized recommendations in e-commerce and entertainment by analyzing user-product relationships. In healthcare, it can support diagnosis and treatment decisions by linking symptoms, diseases, and medical evidence. In finance, it can detect suspicious patterns across accounts. And in legal or enterprise settings, it can make knowledge retrieval much faster and more accurate. The biggest benefit of GraphRAG is that it brings relational reasoning into the retrieval pipeline. That improves contextual accuracy, especially in domains where facts are interconnected. But it is not easy to build. Systems must handle scalability, efficient graph storage, fast querying, and smooth coordination between components. Reliability across multi-step reasoning is also a challenge. On top of that, privacy, safety, and explainability remain important concerns, especially in sensitive sectors like healthcare, finance, and law. Now that we've covered users and limits, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. Which of these is a strong use case for GraphRAG mentioned in the article? The correct answer is decision support in healthcare. The article highlights healthcare decision support as a major application where GraphRAG links symptoms, diseases, treatments, and evidence. Question 2. Why is GraphRAG useful for query-focused summarization? The correct answer is it synthesizes graph-based insights around a query. GraphRAG can organize entities and relationships into graph communities, helping it produce more comprehensive and diverse summaries. Question 3. Which is a major challenge for GraphRAG systems? The correct answer is scalability with growing data volume. As graphs and data volumes grow, storage, query optimization, retrieval efficiency, and system integration become difficult. That's it for this lesson on GraphRAG. If you understood how graphs improve retrieval and generation, you've already got the core idea. Keep exploring, because systems like this are becoming very important in enterprise AI. See you in the next video.